So our given question is, that is our question number 18. It is given a beam of light consisting of two wavelengths 4000 angstrom and 6000 angstrom is used to obtain interference fringes in a YDAC Young's double slit experiment. Okay, what is the least distance from the central maximum where the dark fringe is obtained? So now see how to solve this in this question. So in this question, two data are absent actually, so you have to think, okay, what is that absent data. Now see, so in YDAC there are two slits, we know there are two slits, these are the two slits, okay, and here is our screen, okay, and this is the location of central maxima. Okay, so distance between two slits, this data is not given in this question paper, so but in marking scheme, in Cbse marking scheme, it is mentioned d is equals to 1 centimeter, so we can take d is equal to 1 centimeter, and small d, distance between the slits, and distance between, this is the location of slit, and distance between slit and screen, distance between slit and screen, it is written as capital D, it is 1 meter. Okay, yes. So now see how to solve this question. So in given data, given lambda 1 is given 4000 angstrom. So 4000 can be written as 4 into 10 to the power 3. 1 angstrom means 10 to the power minus 10 meter. So it will be 4 into 10 to the power minus 7 meter. This is lambda 1. Similarly, lambda 2 is given 6000 angstrom, that is equals to 6 into 10 to the minus 7 meter. Okay, and we know that for dark fringes, keep it in mind, for dark fringes, these are the two formulas. For dark fringes, we know y nth dark is equals to 2n minus 1 lambda capital D by 2d. Okay, and y nth bright, that formula is, here bright is not asking, about bright it is not asking, so no need to write. So y n d, 2n minus 1 lambda d by 2d. If you will put 2n minus 1 lambda d by 2d, so remember here n value starts from 1 2 3 dot dot. If you will use 2n plus 1 lambda capital D by 2 small d, then n value starts from 0 1 2 3 dot dot. So as per the given data, y1 will be how much? So now read the question. It is used to obtain interference fringes in a YDAC, and what is the least distance from the central maxima where the dark fringes is obtained. So as it is asking about the least distance, that means the dark fringe is first dark fringe, obviously, otherwise the distance will not be least. So y1 for first wavelength, so it will be, as nd value is 2n minus 1 lambda d by 2d, so you can think y1d is how much? 2 into 1 minus 1 lambda capital D by 2d. So it will be lambda capital D by 2d. Okay, so finally you can write y1 for first wavelength. First dark fringe will be at lambda d by 2d. Lambda value is 4 into 10 to the power minus 7, and its capital D's value is 1 in SI unit 1 meter. 2 into small d value 1 centimeter, so that means 10 to the power minus 2 meter. So it will be 2 into 10 to the power minus 5 meter. Similarly, what is the y2 value? Y2 means what? Y2 means for wavelength lambda 2. What will be the, where will be the location of what? What will be the location of first dark fringe? So y2 is equals to same formula, lambda d by 2d. So lambda value is 6 into 10 to the power minus 7 into 1 divided by 2 into 10 to the power minus 2. So it will be 3 into 10 to the power minus 5 meter. And now come to the question. So now the last line is very important. What is the least distance from the central maximum where the dark fringe is obtained? Okay, so this is the location of y1. This is your y1, and here is our y2, suppose. Yes, so for the, so what you have to write? For both the wavelength, where is the location of first dark fringe. So first we have to write first dark fringe will be at distance where both dark fringes will coincide. Okay, that means in order to obtain this, we have to take the LCM of, that is the LCM of y1 and y2. Okay, suppose if I will ask 15 is a number, okay, that is available in 3 table, that is also available in 5 table. Yes, so this is, and also so many numbers are there, okay, which are available both in your 3 table and 5 table. So what is the minimum, which is one is the minimum number, okay, which one is the, and the question is what is the minimum number which is available both in 3 table and 5 table. That means we have to take the LCM of 3 and 5. Same thing, we have to take the LCM of y1 and y2 in order to obtain the least distance from the central maxima where the dark fringe is obtained. So the LCM of y1 and y2 is, so LCM of y1 and y2 is what? y1 value 2 into 10 to the power minus 5 meter and y2 value 3 into 10 to the power minus 5 meter. That means we have to take the LCM of these two, that the answer will be 6 into 10 to the power minus 5 meter. This is the answer as per the question. Okay, in the question number 18, actually another question is available in our question. That question is, now see, in YDAC using monochromatic light of wavelength lambda, the intensities of two sources are I. So what is the intensity of light at a point where path difference between wavefront is lambda by 4? Okay, so in previous year board question, actually same type of question is available in your section E portion, section E part. Okay, so let's solve this question. We know in case of interference, what is the net intensity formula? Now recall, net intensity I net is equals to I1 plus I2 plus 2 root I1 I2 cos phi. Okay, so as per the given question, as I1 is equals to I2 is equal to I, so the above formula becomes I net, that will be equals to I plus 2 into root over I into I cos phi. Simply you have to solve. So the answer is I plus I is 2I plus I square root over is I 2I cos phi. So now we can take common 2I, take common, it will be 1 plus cos phi. And you remember 1 plus cos phi is 2 cos square, it will be 2 cos square phi by 2. So the answer will be 4I cos square phi by 2, where phi is your phase difference. But as per the question, your path difference between wavefront is given lambda by 4. So from path difference, how can we calculate the phase difference? That is the main challenge for us. So we know phase difference del phi equal to 2 pi by lambda into path difference, and given path difference del x is equals to lambda by 4. Now we can put, so 2 pi by lambda into lambda by 4. So it will be pi by 2. So your phase difference del phi is pi by 2. Now we can easily calculate the I net value. So net intensity as per the question, 4I cos square, instead of 5 we can write pi by 2 whole divided by 2. So it will be 4I cos square pi by 4, and cos pi by 4 is 1 by root 2, its whole square. So it will be 4I into 1 by 2, that is 2I. So this is our final answer for the given question. Now you can solve it in this systematic way. So thank you, have a nice day.